First thing I have to say, so his French and his name is pronounced Denny, like Danny, but Denny. Don't pronounce the last S. So it's not Denise, it's not the Dennis, it's Danny. So after that, first disclaimer and introduction. So I just have to say that yeah, we're very glad to have him here. A few years ago, when I first met Denny, I remember that he told me that he was like a Swiss knife of research skills and tools. So he's an electrical engineer with automation, with in his career has done with mechanics and electrochemistry, biomaterials, and enzymatic fuel cells. So he had a very broad skill set, which is very handy to have in a group like ours. So. So Denis is now a Marie Curie fellow with an individual fellowship that he got last year. Actually, I have to say that he was applying for most of the fellowships available to come here to Barcelona, and he got them all. And in the end, we decided to go for the Marie Curie. So he will be here for the next 2 years, as he will explain. And yeah, so we're very happy to have him with us. So without much much else to say, I'll hand it over to Danny.
Thank you for
There you
the
go.
introduction, Juan Pablo, and hi everyone. So yes, I'm very glad to have the opportunity to present you the project for my Marie Curie Fellowship. So I will refer to it as throughout the presentation as GREAT-4PA, and so the acronym actually stands, as you can see in the title, for Green Autonomous Transducers for Precision Agriculture. So to implement the project, I joined the Speed Research Group. So at the beginning of the year. So the Speed Group, if you don't know it, is part of the MESI group here at the CNM, and so it is mainly involved in the development of sustainable power sources that are then coupled with electronics, so to create self-power devices. So in my case, we are targeting applications for agriculture, but for instance, the group has previously reported patches for smart patches for biomedical related applications and the like. So the group is led by Juan Pablo and Neus. The activities of the group have led to the funding of a spin-off, Fuelium, so which commercializes paper-based batteries. Fuelium is also a partner in the project. And so if you're maybe curious and want to know more about the group, maybe you can refer back to some of the previous talk of the Friday talks, because some of my colleagues, so in particular Marina and Nuria, already presented their works during a previous session. So maybe you can watch their videos, and you can also obviously check out the website of the group. You're going to find a list of publication and so on. So as I briefly mentioned, the context of the project is agriculture. And so why is it important? Well, the fact is that European agriculture is facing big challenges. So I'm going to maybe oversimplify a little bit the situation, but we can say that on one side, we have always more constrained resources for agriculture. So you may think about water in some part of the world. It may not be the case yet for Europe. But so, for instance, when you look at the figures, you can see that actually in Europe there is like a steep decline in the number of farms, for instance. And in parallel, you still have this fast-pacing urbanization, so with the expansion of cities, and so literally, let's say the buildings tend to eat some lands that were maybe used before for agriculture. And on the other side of the balance, let's say there is still an overall growing demand for food. Um, so even if you want to consider that, let's say some predictions in Europe tend to say that in the near future, the growth population should reach kind of a plateau and stabilize. The fact is that some other parts of the world are still booming, and so there is still this strategic question, economical question about also how Europe and the European countries would like to be key players in this global food trade. So it's not like the situation is like brand new. Maybe we can say it has evolved or even worsened, I mean, over time. But I mean, this need identified to boost the productivity, I mean, has been identified like probably decades ago. And so it has been mainly addressed using intensive agriculture. So here I will refer to intensive agriculture by the fact that uh, as input, so you're going to use a lot of chemicals that can be fertilizers, pesticides, herbicides, and so on. I mean, everything needed to like cherish and make sure that your plants can grow in the fastest way possible, and also in order to have like the highest outputs possible when you harvest the fruits or cereals and the like. Well, I mean, in retrospect, now I guess we'll all more or less know that, I mean, this intensive use of chemicals, it's not really sustainable and not really eco-friendly. So the chemicals can go deep into the soil and reach the water levels. So here is just like a very short example. Uh, so I don't know if you have this kind of green tide in Spain, but I know for sure that this is a phenomenon that occurs along the coastlines of Brittany, this region in France. And so basically, you're going to have this big accumulation of sea lettuce on the beaches. Mainly when, I mean, you have several factors that play, but one of the main reason is because of the excessive accumulation of nutrients that mainly come from human activities, and in particular intensive agriculture. And so one of the points is like, it's just like it may look ugly on the beaches, so it's not nice to see, but it's actually also dangerous because when you take the seaweeds and if they dry on the beach, actually during the decomposition process, you have a toxic gas that develops and is released, and so actually without knowing it, you have several persons in France that walk, I mean, on the seaweeds, and that actually get trapped, I mean, with the gas, and so died in this way. So, I mean, I could have taken many other examples, but I mean, one big conclusion is that, I mean, agriculture needs like new practices, and we need a new paradigm for agriculture, and this is where precision agriculture comes into play. So with precision agriculture, we still want to have the high inputs, the high outputs. Sorry, we still need to have this good productivity. But the idea is to optimize the whole agricultural process. So with this idea that we can use much less inputs and so much less chemicals at the beginning of the process. And so, I mean, the main idea of precision agriculture is so somehow to help farmers to take the necessary actions in a more informed and timely manner. So how can we do that? The first approach, uh, first possible method is to use geospatial image analysis. So here the idea is that we're going to take high altitude images of a field, for instance. So you can do that using airplanes, helicopters, drones, even satellites. And so from the images obtained, you're going to apply signal processing techniques. So in order to extract pertinent, relevant information from the images. So one example is like, for instance, if you have a fungal disease that starts to develop in a field, it is very likely often the fungus when it develops on the leaves of the plant. I mean, it affects the leaves and it can change its color. So actually, this is going to be on the field scale. This is going to be affect the reflectance of the light. And so, for instance, like on this image here, it's just an illustration. But so you're going to see different zones in different colors, and so the farmer can know actually that maybe a disease is developing in one part of the field, and so he can start to treat immediately for the disease, or at least go to the field and see what's happening. But so the idea is that in this case you can treat only a small parcel of the field, and you don't need to try to treat the whole field uniformly at the same time. So it's kind of a very powerful technique, very powerful approach, which offers like a high spatial and temporal resolution. So you can go down to the centimeter, you can count the number of plants across a field. But the downside is like, yeah, it's pretty costly, let's say, especially you can imagine, I mean, if you want to get images from satellites, I mean, probably the farmers after needs to be in touch with some kind of consulting company, which owns the algorithms and everything, I mean, to process the images and give the information to the farmer. The second approach, so we're going to be much more focused on this one, considering the expertise of the speed group. So this second approach is like based on wireless sensor networks. So this time the study is to deploy multiple nodes or units across the field. So still with this idea is that you can access relevant local information, so like temperature, humidity, and with this idea that you can derive local weather forecasts. So maybe the farmer can know that with this humidity and this temperature, I mean, you have the good conditions for the development of such a disease. So it can try to anticipate and maybe treat before the disease can even like arise in the field. So it's kind of a cheaper approach. The problem is that, to the best of my knowledge, most of this configuration are actually deployed in vineyards and, for instance, olive groves. Because if you see on the images, we are still talking about like big boxes of plastic with all the electronic components inside. You may have solar panels to provide the energy to the whole components. And so the problem is that there is a large part of agriculture. So if you consider, for instance, this kind of tall cereal crops, so if we are talking about wheat, corn, and this kind of field, you can see that even like if you are considering such like a device planted in the soil, well, you can imagine, first, it's not very simple for the farmer in all this, like in all these plants. I mean, how can you even like detect back the sensors? And I mean, you cannot ask the farmer to retrieve, to recollect the sensors before harvesting. And even if you have a solution for that, the point is that with like conventional electronics, we are still talking about units that contains a lot of various toxic materials. So usually you have antennas, microchips, batteries inside. So anyway, it's not like devices that you can imagine to live in the long term on the field. And this is actually the kind of shortcomings we want to address in the GREAT-4PA project. So basically, the objective is to develop like game-changing nodes with new features compared to what I've just shown. Sorry. So we decided to obtain a global device that ideally could be completely degradable or even better compostable, so that it could operate and do its function for stable operation of time. And so after that, you could like just leave it there without like any negative impact for the environment. And this is something we have imagined based on the battery, sustainable batteries previously reported by the SPID group. So maybe some of you know it. So, but this is like an old battery design. So the power pad. So this is a battery that actually you can trigger by using any kind of liquids. So if you put like a drop of water in the center here, the battery will start to generate electrical energy. And so you can see here that actually some studies have been conducted with this idea, so that the device is completely degradable and is not harmful for the environment. There's a second big feature that we want to try to achieve in the project, because I don't know if you have noticed, but so far I've always talked about sensing capabilities. So with this idea that you can measure temperature, humidity, and this way the farmer can take an action. One of the idea of the project is like, yeah, what about if we could go a step further? And so having also this capability maybe to have some kind of mechanism to, when needed, directly release some doses of agrochemicals directly close to the plant roots. So for instance, like a mechanism a little bit derived from drug delivery that you can get from the biomedicine field, let's say. So this is a global, let's say, overview of the work plan and the different tasks of the project. So with this idea that one of the first steps is to tune, let's say, the battery design with respect to the specificity of the applications related to agriculture. So for instance, we are planning to have the capability to trigger the battery over different time scales. So to have different measures of the first week, 1 month after, and the like. And so different functionalities that we want to implement. So I have spoken a little bit about this capability to deliver some agrochemicals. Obviously, we want to also have a functionality. I mean, one biodegradable sensor, so most likely temperature or humidity. And another challenging part of the project is that ideally we would like to have some kind of receiver transmitter stage, so to be able also to retrieve the measure from the sensor, and also maybe to communicate and trigger the delivery of the agrochemicals when we want. And so this is a bit this long-term vision where we are foreseen maybe this kind of application, or because at the end, I mean, we are talking about paper-based battery, and I mean very low-cost materials and the like. So we would have very cheap devices. So the idea would be to have maybe like a drone with a payload and multiple devices. The drone could fly over a field, and so like just drop some of the sensor where it is needed. It could register the waypoints, and so go back to the location where he dropped the sensor to maybe retrieve some information, and also maybe trigger, I mean, give some orders to the devices if needed. so for now, just like a short status. So the project I started only a few months ago. So I'm still more focused on the first part, and let's say the battery. But so this is just a short update about what we had reached before. So I have worked with Marina and Carlos with one of the device of a battery that they have like reported before, and so we have tried to connect this battery with a bit of electronics, and we have been able to drive so what we call a flower care sensor. So this is this kind of commercial sensors that you can put in the pot of a plant. And so a bit same idea, you have multiple sensors inside. You can know about the light exposure, the humidity you have in the plant, the temperature. I mean, if you need to put some more water to make your plant beautiful and the like. So obviously it is still not like biodegradable at all, but so this is the next step of the project, and so I'm going to here so try to make all this let's say at least maybe green or greener. Let's say I won't say it's going to be greenest, but okay, that's it. Thank you. If you have any questions, obviously.
Thanks, Danny. Wonderful presentation.
Thank you.
Yes. So now the virtual room is open for questions, and we can take them open mic or written in the comment section. I hope you've gotten the general idea of what he's doing, and is basically taking some of the concepts that we have in a group a bit further and into some specific applications. Of course, the first comment comes from
this is a problem with the acronyms. I mean, it's so yeah, it's a bit, yeah, that's for sure. I didn't think about this one before, but yeah.
Yeah, it looked like yeah, with the testing on animals it won't be part of the scope of the project, but yeah, just about this comment of our new director, if it's if the acronym GREAT-4PA is misleading. Hopefully not for everyone. So maybe Danny, can you elaborate a little bit on the inspiration of, for example, this actuator to release agrochemicals, because you were part of a project, a collaboration in your previous institute, where it was a bit of the inspiration, right? But with the medical.
Yeah, exactly. So I mean, we're still working on this, but so I mean, the main idea, let's say we've come up with, it's because in my previous institute, indeed I worked with people who were involved in the development of drug delivery devices. So mainly working with these hydrogels containing active molecules, with this idea that you could put this on a patch, and so with this idea that the active components could go through the skin, and so you could have some effect. I mean, depending on the disease and the like. But yeah, so one of the first idea was to try to transfer this kind of idea, having, so let's say, a porous structure like a sponge actually, that could like maybe have. I mean, some active components inside, and so in contact with water, I mean, it could like swallow and maybe release some doses of interesting chemicals. So in this case, for the plants, not like for some medications. So now, I mean, we are also considering other approaches that are going to be tested in parallel.
Yeah, so related to this first approach, I think we have a question from Ferran. It's a very nice project. What could be the triggering factor for the release of chemicals?
Yeah, so for this, I mean, it's a good question. It's still actually an open one. So actually, it would be nice. So this is also an objective of the project for me to be a little bit more trained and to make contacts and also speak with people from the agriculture side, because I mean my background is not on this one. So this is why, for instance, even for the sensor, I said we will probably select like a temperature sensor or a sensor for humidity. Maybe we could combine both. So, I mean, for now, the idea would be in a very, let's say, more complex scenario, being able to read, so a measure, let's say, so the temperature is maybe too high, we need to do something on the plant. So either there would be a scenario where the device would be able, so you reach like kind of a trigger which is detected and we release something. Otherwise, it could be this idea that we just get the measure and remotely, if we can do this receiver transmitter stage, the idea is that someone could decide to release from a distance the chemicals. So I would say for now, this is the two main idea that I have in mind. Obviously, they will probably change a bit, but.
Sure. Yeah. Maybe the link that is still is not clear is the fact that how we're envisioning the system is that the battery is going to react to the environment and is going to produce more or less power depending on the conditions, and this will affect the releasing of the agrochemicals. So it's again leveraging some of the concepts that we have in the group, in which batteries can also act as sensors, collecting information from the environment and then acting in this case. So in this sense, also the question from Eli is, do you have already said which agrochemicals do you want to release? Is that important in terms of modifying or adjusting the transducer functionality? I think it's more or less what you were commenting already.
Yeah, indeed. So no, it's still an open question. Indeed, I think let's say the molecules. I mean, the active substance, for instance, depending if you are talking about hydrogel or power structure, I guess the size of the pores can be affected depending on the chemicals you wanna use and release on the plant. So it's true that this is something we still need to discuss with this idea that we want to have something that could be effective if it's like close to the roots of the plant. So
sure.
For instance, not like a chemical that usually you spray on the leaves, I mean, for treating the plants or whatever. So it will be more in this direction that we will.
Yeah. It's more a dosification of the chemical over time rather than a punctual release of a very high concentration. So it's more about controlling how the same amount is spread over a longer time, so that the absorption and the effect is more efficient. And in this sense, also Luis is asking, which size do you envision for the whole node?
Yeah, it's not so easy to. I mean, the idea is to still. I mean, try to integrate everything in the size and the dimensions of the battery available. So we are trying to have everything with a size of a few, let's say, centimeters. I mean, ideally that would be that. After, for instance, for the transmission stage, I mean, the coils and stuff like this. I mean, depending on the distance we want to activate, all this can also play. But so the idea is to have something, let's say, as small as possible, but we still need with the battery to generate enough like energy. So I mean, everything is a bit like intercorrelated. You need to produce enough energy to activate the function. So we need to to tune a bit everything to make like a wall. But definitely the idea is to have something that could fit on the footprint of a battery, which is, maybe you have seen some of the picture with Juan Pablo. You see, I mean, this kind of size that you can take in your fingers, centimeter scale, let's say.
Sure. So another question is, which component will be more challenging from a biodegradability point of view?
So in my view, for the battery, normally we already have the expertise in the speed group, let's say, to achieve like rapid results on this side. On the sensor side, so to measure temperatures or whatever, you can find a lot of work on this side as well. For instance, you have already biodegradable sensor for measuring temperature for the food chain. For instance, I've already seen people, so you put like a patch on the fish. So you have the fresh fish, and you want to be sure that when they are traveling, the temperature of the fish is always good. So you have like groups developing this kind of temperature sensors, which are completely also, eco-friendly and not toxic at all. So this is also something we can, let's say, rely on in the temperature, in the literature. Sorry.
Mm-hmm.
For the drug delivery release, also I think most of the things are made to be, let's say, biocompatible. Not harmful for the body. So I think it won't be the most difficult part. I would say the very big challenge is this communication stage. So to transfer really the information, especially if you want to, think about it, because we are talking about a field. So if you need to be very close to the sensor, to the nodes, it can be difficult. But the project is already a first step. But I think this is where it's going to be really more challenging, because here we're going to, need probably more like real electronic stuff. So, you can find for sure, this kind of both electronic circuits that are made biocompatible, but the point is like beyond the lab stage, to make it like usable and useful in the field of agriculture. I think this is going to be the real big challenge of the project.
Exactly, and that is forcing us to move to non-conventional electronic approaches, and this is also one of the skills in our group, to find the simplicity in thinking differently from the electronic point of view. And also, like in parallel, biodegradability is something that we are assessing in collaboration with other research groups and institutions, making a broad screening of materials that could be good candidates for this type of developments. So I have another one here. Did you thought about combining your technique with measurements from satellites?
So I think it's a good. So probably when I combined, I presented sorry these two separate methods. So each one having this advantages and disadvantages. I think one of the very clever idea, and probably like many things in life, would be to combine both approaches. So maybe having a bit of the sensors, and maybe for some larger areas, relying on the analysis of images. Within the context of the project, no, it's not something we have planned for, because it's already challenging. We need the expertise of people for the agriculture side and so on. And my background, related to satellites and so on, it's a bit too far. So, but this could be something interesting to develop in the future. I think the combination of both approach, you could have like the benefits of a bit of everything.
Sure. It's always interesting to collaborate with people working with satellites and spaceships. Then final question, I think the releasing part will work for a plant. but for a field, you will need many of those devices, don't you?
Yeah, indeed. It's also one of the challenges. So one of the strengths of the approach, it's like I mean, with the device, I mean, the key idea is that it would be very low cost. So I mean, it would be really normally easy to scale up. I mean, the idea is that anyway to design everything to scale up the approach. So yeah, I mean, the idea is that after we would be able, because it's low cost, it's not harmful. I mean, like you could like put many of the devices because it would be cheap. It would be cheap over the field. But yeah, I mean, for sure, it's also one of the difficulties. So we are taking it like one step at a time. So we are working with the plant first, and but so normally the whole idea is that it would be cheap and scalable. So we hope that this could work for the field actually.
Thanks.
But there are a lot of questions actually.
Yeah. There's more people now. More skepticals. What will happen with the chemicals that won't be released when the devices will degrade? This is like when the power pad that we had different chemicals that in the end they neutralize themselves. So you just needed to be working during the operational time, and then the outcome after the operational lifetime is that it's something either neutral or beneficial for the field.
Yeah, indeed. I mean, the idea is that, yeah, indeed. I mean, even if the device would fail, I mean, it couldn't like do the function, and I mean, nothing would be released. Yeah, normally the idea is that it wouldn't be harmful anyway. It's just that the chemical wouldn't do the job for the plants at the proper time. But it's like it shouldn't be bad.
Sure. So, anyone else? Last chance to interrogate any. So, last. So you will not deploy them. You will saw them. Typo or
Yeah.
Sembrar. Yes, exactly. This is to plant, right? To spread like a seed. Actually, one side project of the project that we were considering is to make them the size of a seed and spread them together with seeds. So this is even a more challenging approach, but it's something that we are brainstorming.
So I have like learned one word of Spanish.
Yeah, sembrar. You see.
Because I didn't know this one.
Cool. All right. Well, let's thank Danny again and make
Thanks for your attention and the question, guys.
Some virtual clapping. There we go. And hopefully, we get to see him achieving all of these objectives in the future.